When you stop watching this video, please tell me what the reason for it was, so that I can improve. Otherwise, hi and welcome. I'm trying to learn biochemistry today, acid-base balance, the concept of pH. And after we've done it, we're gonna do leg injury prevention training. And if you participate in the leg injury prevention training, then it's at your own risk. Now, we read it in the previous part, and now we're trying to make a presentation about the pH scale. So we're going over the text, trying to find information about how a pH scale works, maybe with one or two examples, and then we're trying to memorize it and making a presentation about it, how the pH scale works. To ensure homeostasis, intracellular and extracellular fluids must contain almost balanced quantities of acids and bases. The more hydrogen ions, H+, dissolved in a solution, the more acidity the solution. Acidic the solution. So the solution is acidic, and it has the acidity, so it would be acidic because there's acid in it. Acidic. Conversely, the more hydroxide ions, the more base, alkaline the solution. The chemical reactions that take place in the body are very sensitive to even small changes in the acidity or alkalinity of the body fluids in which they occur. Okay, now one more. Any departure from the narrow limits of normal H+ or OH- concentrations greatly disrupts body functions. Okay, the human body bases or alkaline are used to make the acids part, the H+, not so acid. And the human body has to have a pretty exact level so that everything works properly, intracellular and extracellular. And the human body uses alkaline to bring the acids on a good balance. A solution's acidity or alkalinity is expressed on the pH scale, which runs from 0 to 14. Okay, that's the first one. 0 to 14. pH scale 0 to 14. This scale is based on the concentration of H+ in moles per liter. 1 mole are 6023 times 10 to the 23rd amount of atoms of this acid in it. That is the Avogadro number. That means if there would be 1 mole in it, that means that there is 6023 times 10 to the 24th amount of acid molecules in, which would be very little on the liter C. A pH of 7 means that a solution contains 1/10,000th of a mole of hydrogen ions per liter. But if you think about it, that's still a lot. If 1 mole are 6,000 times 10 to the 23rd, so that is 6,000 with 23 zeros, having a 10,000,000th of it is still a lot of acid. But it's just, you just take 7 zeros away, so you have still 6 with 16 zeros amount of acid in it. You still have 6 quadrillion or whatever of acid in it. It's just with the other rest is still much more. But it is a lot. So pH 7 means there is 0.0000001 mole in it. The number 0.0000001 is written as 1 times 10 - 7 in scientific notation, which indicates that the number is 1 with the decimal point moved 7 places to the left. To convert this value to pH, the negative exponent -7 is changed to a positive number 7. The amount of zeros after the point are the pH thing. So if there is technically pH 0, it runs from 0 to 14. 0 to 14, that's important. It can be 0. Sure, but it cannot be more. There can be more than 1 mole of acid in a liter. Whatever. 0 means that there are 0 zeros after the dot. But there is just 1. 1 mole acid is now in the liter. If we're having a pH of 1, we're having 1 zero, so 0.1. It's the first one after it. Not the zeros, but how many of places after the 0. So pH 1 is 0.1. pH 2 is 0.01. We're having now 2 after the dot. And pH 3 is 0.001. We're having 3, 0, 0, and 1. That is why pH 7 is 0.0000001. 1, 2, 3, 4, 5. I think give us 6. 6. So 7 means the 7th one is number 1. So we have 0 point and then 3 and 3 and then 1. Minus 7. So the 7th one is our number. pH 0 would be just the 1. There's nothing behind the dot. And pH 1 is 0.1. That makes sense. It's not the amount of zeros, but the first one who is the amount of digits after the dot. And if you're having now 5 digits after it, the 5th digit is a 6, so 0.00006. That means there are pH of a 6 digit pH 6 of 6. And in this case, pH of 6. A solution with H plus concentration of 0.0001, 10 minus 4 moles per liter has a pH of 4. A solution with H plus concentration of 0.00000001 minus 9, pH 9, moles per liter, and so on. So amount, so it has been 0.0001 of 6,000 to the 10 to the 35 of moles in it. So still 6 quadrillion or whatever the number would be. The midpoint of a scale is 7. Why? Where the concentration of H plus and OH are equal. Because you can calculate the other way around. It starts both by 0, and if it has the alkaline number by minus 14, then it would have very little alkali and very much acid. Better to remain with it. And by 7 they are exactly balanced. So when we're having some of the alkaline and some of the acids, they're balanced. 7 is the midpoint. A substance with a pH of 7, such as distilled pure water, is considered to be neutral. So it is neutral. So there can be acid in it. But it is fascinating. No, I'm not completely sure if it's true, but imagine if it's true. There can be acid in it, but because there's alkaline in it, it's still neutral and it's not an acidous drink or whatever. And that makes totally sense. Otherwise, so that means there's everywhere acid. Just that there is now the alkaline, so that it's not everything full of acid. It seems like you can't get without that with acid. And imagine that would be necessary. Imagine there wouldn't be any alkaline, then everything would be acid because everything has to be super clean. And it seems to be impossible. If distilled water still has 0.00001 of the Avogadro number of acid molecules in it, that is quite a lot of acid. But it seems to be no problem. It is distilled water, completely pure neutral water, because there are also 0.00001 mole of alkaline in it. A solution that has more H plus than OH minus is an acidic solution and has pH below 7. So if it has pH 2, it is acidic. The solution, it has a lot of acid in it. It is pH 2, so just 2 digits, 0.01. That is quite a lot more than 0.0001. So pH small means only very few numbers behind the dot, so it's almost a full mole in it. A solution that has more OH7 than H plus is a basic solution, or alkaline solution, and has a pH above 7. It is important to understand that a change of one whole number on the pH scale represents a 10-fold change from the previous concentration. That is a lot, it's a 10-fold change, not a little bit, but I still don't get it. If the Avogadro number is such a big number with 6023 times 10 to the 23rd, why is now 1 0 making such a big difference if we're speaking about the 23rd? So the whole number, it's still, as I said the whole time, sounds so much 0.001 of these 6 quadrillion in it. Why does it meet there? And not somewhere further behind. By 23 numbers, we're meeting already by 6 or 7. A pH of 1 denotes 10 times more H plus than a pH of 2, whereas a pH of 3 indicates 10 times fewer H plus than pH of 2 and 100 times fewer than H plus than pH of 1. Okay, I think we're just going to start the camera and we look what comes out. the pH scale goes from 0 to 14, and 7 is the middle part. And that means there are the acids and the alkaline on the same level by pH 7. 7 means that the seventh digit after the 0 is used as amount of mole of acid in it. So pH 7 means there are 0.000001 of a mole of acid inside of this liquid, whatever. And also the same amount of alkaline. It is 0.000001 of alkaline in it, and there it is neutral. 7 is the midpoint. There is the same amount of alkaline bases or basic as acids in it. With it is it neutral. 7 is the neutral point. If it is less in the pH 2, it means it's just the second digit after the dot. It is 0.01, for example. That means there are already 0.01 of a mole of acid inside of this liquid, and very much less alkaline. And alkaline is OH minus and acid is H plus. And that is the whole thing. pH means how much acid in it is. By 7 it is neutral, there's the same amount of alkaline as acid in it. It's 0. And then the seventh digit after it, so 0.000001, and alkaline also the same. If the pH gets higher, it's more behind the digit, which means the amount of molecules in it which are acid are less. So a pH of 14, which is the highest one, would mean 0. And then the 14th digit would be the 1 of a mole of acid in it. And then down the same, and the pH of 0 would mean there's 1 mole in it. And 1 mole is 6023 times 10 to the 23rd amount of acid molecules inside of it. So that's how they divide it. 7 is the midpoint, where it is neutral, same amount of alkaline or bases as acids. If the pH gets lower, pH 4, it's just the fourth digit instead of the seventh one by pH 7, and now the amount of a 1 is higher, so it's just 0.001, 0.0013. So the fourth digit, pH 4, 0.0001, is much closer to a whole 1 than it is by pH 7. That's the midpoint, and pH 10 would be 10 digits. That means it is far away from being a whole mole. And that's always a tenfold. So if you have pH 3, it is the third digit after 8, 0.001. That means 0.001 of this Avogadro number of 6023 times 10 to the 24th amount of acid is in it, quite acidus. And then there's no less alkaline in it. So that is now out of balance. If you bring it into balance, it meets at 7 and 7, because 0 to 14 is a scale of the pH. That is according to Gerard Tutor and Grabowski's Principles of Anatomy and Physiology book on the page 40 and 41, but this is no medical or measuring advice. I'm going to stop the camera. And that was the biochemistry part. If you were here for biochemistry, you can go directly to the next part of biochemistry. If you stay here and participate in the 2-minute leg injury prevention training, then it's better on with the standing good and swinging the leg to the side and in front. Other leg, swing it to the front and to the side. And now bring the foot in front and back. Other one in front and back. Now bring the leg up, arms out, and go with the arms over to one side and with the leg to the other. And change. Middle and down, other one up, and go over to one side. Over to the other one. Middle and down. Leg up and press with the knee up and to the side. Other one up, press up and to the side. And now stand good on one leg, turn slowly over to the leg, that exercise can go to the leg, or the knee. Go again down, turn over to the other side, all carefully and slowly, and up again. Other leg, stand good, turn carefully over, down into the knee, turn over to the other side, and go up again. The clock, stand good on one leg, and go to the imaginary 90-minute intervals on an imaginary dial of a clock. Always with a knee a bit down. This exercise can go again. Other leg to 12 o'clock, to 1:30, to 3, 10:30 and 9, and 7:30 and 6, 4:30 and 3 o'clock. The horse, leg in and out. And on the camel, the whole body comes out up and down. Other leg, the horse, leg in and out. And now the whole body. And stand good, legs wide apart, breathe in and down. Breathe in, close the legs. And breathe in and out. It was a shortened leg interval training. I thank you very much and until next time.